In the previous video, we have implemented some helper methods in our corridor node class, and now we are going to proceed by implementing the process room in relation for up and down and left and right directions. First, let's do the right or left implementation. So let's delete the throw statement, and here we will need to create a temporary node left structure equals null. Because this is type of node, you can place the corridor in your hierarchy and use it for creating new corridors. I didn't implement this solution, but you certainly can. List node. Okay, we need list, yes, and we need to be using system collection generics node, and we need left structure children. So this will help us get the left structure children, and we will call structural helper and call our traverse graph to extract lowest leaves, and we call structure 1. So if structure 1 has no children, it will return this itself, otherwise it will return the children. Okay, and we need to pass it, okay, room node. We don't need necessarily to pass it room node, we can pass it node, and it should be working well. Okay, save it. So we have modified traverse graph to extract lowest leaves to take on node and not room node. And now we can call the same. So let's create node and right structure equals a null and list node. And we will look for right structure children equals structure helper dot traverse graph, and we call structure 2 on it. Okay, and now we need to sort our left structures. Okay, so let's look at the example. Let's say we have this kind of structure and we want to connect those 2 rooms with those 3 rooms. Remember, those are the parents. This is the dividing line, and those are the parents. The parent has those children in them, and let's say those are connected already, and we have those connected already, and we need to create a final corridor, and we can get the list of children of this space, and let's say this is the first one. If we take simply the first one, we will connect this room with, say, this room or this room, going through this middle room, and this is an issue. So that's why we will order the rooms. So we extract the rooms most to the right in the left structure and most to the left in the right structure by sorting them simply by axis, and then we will know that this room can be connected with this room. But not exactly like this, because this room might want to connect to this room and might want to connect to this room, but this room can only connect with this room because it can't reach this. So we will need additional sorting for that. So let's go back to the code. Okay, so first we want to sort, and I have chosen left structures first. So let's call var sorted left structures equals left structural children order by descending, and we should import using link. Okay, and now we can sort those by child lambda expression child dot top right area corner dot x to list. So what we have done here, we have sorted all the children of the left structure by the x value of the top right area corner of each of the structures. So basically what I have shown previously in the slides. And we know now that those are the most right aligned structures in the left structure children list. Okay, we need to remember that our structure can have no children. So if our sorted left structures that count is equal to 1, sorry, we will set left structure equals to sorted left structures dot 0. And otherwise, we need to choose the appropriate structure to test first if it can be connected. So let's create int max x value equals sorted structure of index 0. So top right area corner dot x. And sorted structure list left structure equals sorted left structure dot where. And now we will check children such that math dot absolute value max x subtract child top right corner dot x is less than 10 units. And to list. Let's go back to the slides. Okay, so what we are doing here, let's see this example. We know that this x is the greatest. The distance between this x and this x is pretty small, but against this x and this x is pretty big. So we ensure that we take only those two, as we assume that if this is the biggest x of them all, then the distance between those two is pretty small, and each next room that has smallest distance of x between x's is considered to be most right aligned. That's how we are extracting those most right aligned rooms that could be potentially connected with the right structure. Okay, with all that said, let's create int index and equals to unity engine dot random dot range, and we call 0 to sorted list structure dot count. So we randomly should choose which index do we take. And next we call a left structure equals sorted left structures dot index. And remember, we are saving the sorted left structure list as our new list. So in case this structure doesn't fit our purpose, we can get another structure from our sorted left structures list. Okay, so we now have extracted the most right aligned of the left structures. Now we need to do the same from the right structures. Okay, so we need to sort the right structure children. So var possible neighbors in right structure list. So here we will call a right structure children dot where. Okay, and at the end will be to list for sure. And let's format it a bit. Okay, so here child lambda expression and get valid y for neighbor left right. So get valid y for neighbor left right. Great, and let's format it a bit. Okay, we need the end line ending here. And we will be checking if this is different than -1. And in this method, we will pass left structure dot top right area corner, left structure dot top left area corner, dot bottom left area corner, and our child the top left area corner, and our child bottom left area corner. In the left structure we want top right area corner and bottom right area corner. And in the child we want top left area corner and bottom left area corner. Okay, let's create this method. Generate method. Okay, let's find it. Okay, and here we have the line ending that is unnecessary. So we need to create this get valid y for neighbors left and right method. So first of all, we want to change the names a bit. So let's refactor the names. First one will be left node up. The second one be left node down. and other ones will be exactly the same, but with right node up and right node down. Great. And now we need those checks. So we will call if statement if. So we have specific cases. So let's quickly look at the theory. Well, we have 4 cases. First one, the left structure is bigger on Y's than the right structure. Second, left structure is smaller on Y's than right structure. Next one is that the top point is greater than any point on the right structure, but down point is in between both points of the right structure. And the reversed situation as the last example. So we need to account for all those 4 cases. So let's create if statements to check all of them. Okay, so first let's create right node up dot y is greater or equal than left node up dot y, and left node down y is greater or equal than right node down dot y. So this is the case where the left node is bigger on y's than the right node. And next will be where y values of left node are smaller than right node y values. So right node up dot y is less or equal than left node up dot y, and left node down dot y is less or equal to right node down dot y. Well, you can see we have in both cases equal sign. We should probably choose one, but this is maybe for later. We can optimize this. For now, let's create it to be working. And another case is when the left node's top point is above the right node, so it isn't contained in right node y range. So let's call left node up y is greater or equal to right node down dot y. So basically we are checking if the bottom point of the left node is inside the right node, and based on that we'll create the appropriate y value. Left node up dot y is less or equal to right node up dot y. Okay, and last, let's check if our left node down dot y is greater or equal to right node down dot y, and left node down dot y is less or equal to right node up dot y. So this is the reversed case where the left node top point is in range of right node y's, and the bottom point of left node is outside of the bounds of y of the right node. And we can have the case where the rooms aren't really neighbors in the left-right direction. So we return -1 in that case. Okay, I feel like this video will be very long, so let's continue in the next video.